Hello, my name is Jeff Kim, and I'll be presenting our research on construction workforce training that was assisted with augmented reality. This research focuses on workforce training in the construction industry within the United States. Today in the United States, there are a number of seasoned workers or seasoned practitioners in the industry that are actually retiring at a faster rate than the students that can actually replace them or the new practitioners that can replace them. While construction students obtain most of their theoretical knowledge in the classroom, some of the non-technical items or technical track items cannot be trained because there is a lack of resources available within the industry. So as these students enter the industry, there's a larger number of the practitioners that are leaving the industry, creating a gap in the training. Every year the construction industry is faced with fewer and fewer skilled trade workers that can actually train their replacements. In a secondary sense, this research is also trying to address the productivity issues that the construction industry within the United States faces. When compared to manufacturing over the last couple decades, construction productivity has actually dropped. Now, while this research isn't directly focused on the problem at hand here in this graph, it is surmised that the training that new practitioners will see may improve their productivity over time and also work towards improving the United States construction industry productivity. The immersive aspect of this research focuses on augmented reality, but there are also many other immersive features being used in the construction classroom, such as virtual reality. These extended realities, virtual reality and augmented reality, use in the construction education sector has intensified, with more concentration on workforce development. There are some notable connections between observing a product of the built environment, things like buildings, and viewing those same structures when using XR or augmented reality or virtual reality. Construction management students are able to absorb more information about what they're viewing than when they typically view that content through a lecture or through some reading notes. In a lot of instances, conventional learning techniques that include lecture, note-taking, paper handouts and presentations, and even concept memorization have been proven quite ineffective according to the research. But educators continue to use these techniques because they are resources they're familiar with. The adaptation of learning within this research focuses on an activity in the construction industry of wall framing, which you can see a few examples here on this slide. Wall framing is a work task that often requires a very skilled practitioner. This practice commonly comes across most of the building types that we see within the United States. And in order to do wall framing, you have to interpret finished product from a two-dimensional set of paper plans, and this practice often combines some integration of unwritten procedure, which we call know-how in the American vernacular, and also combining that with mathematic skills and some interpretation of local building codes. So for the rationale for this research, the idea is that we understand that the industry is experiencing a reduction of its skilled workforce. So we have skilled workforce practitioners that are unable to train some of the newly graduated students that are entering the industry. And then we feel there's also a decline in the overall experience of the workforce, which is also affecting the productivity of the industry. Now, there may not be a direct correlation, but there can be some assumed connections there. We believe that technology is a certain way of tackling this problem, and in particular, as we saw prior to this slide, augmented reality has some benefits for allowing students to get a little more hands-on with their learning. This research is focused a little bit more on where construction management students are transitioning from being students to moving to become practitioners within the construction industry. Therefore, where we're getting at is it's surmised that as we improve that incoming workforce, we're thereby improving the productivity of the industry at large. The methodology in this study needed the students to mark the locations along the bottom plate, as shown here, with all the vertical members that were going to be nailed to it in the future. This experiment required them to mark the bottom plate in the correct location, and then the correct markings were scored for each student in each of the different types of methodologies. Let's take a quick look at the methodology. Please feel free to stop the video at any time so you can observe the images or review any of the graphs. For the control group and for the test group, this is the board that they marked. We painted the top of the board so that they could place their marks in a dry erase marker, and then after the experiment was finished with the one student, we would erase the marks and then repeat the study. So the students are getting assessed based on putting the correct marks on these boards every time. For students that conducted or were part of the control group, they would mark the board using this 2D paper plan. For the students in the test group, they would put on a HoloLens headset and then view the holographic image cast in front of them. The next couple screens will show you what that looked like. So as the student viewed through the holographic images, they would see the base plate on the floor and then the elements that were going to be nailed vertically across the top of it. And as you can see here, they would begin the learning exercise, get familiar with some of the terminology, discuss a little more terminology, get an idea of the vertical elements that were going to be attached, and then they would have to match up the markings on the base plate, and then they would see their final product. This is just one more image that shows a close-up of a marking indicator, and this is the research workflow that we use for the methodology. Let's discuss the findings. This table shows the demographics of the students that volunteered for the study. Please feel free to stop the video if you'd like to study the table more. This table describes the markings. There were 20 markings on the base plate, and the students were graded on each of the markings. The marking could either be correct or incorrect. From the data that we tabulated, we assessed an accuracy percentage. So for instance, marking number 1 was stud marking number 1 at a start of wall. The control group is the group that used the two-dimensional paper plans to conduct their marking, and they were 67% accurate on stud marking number 1. The test group used the AR headset, and they were 69% accurate with marking number 1. Again, please feel free to stop the video and to review the table findings. This table reveals that overall the test group outperformed the control group, as you can see by the percentage at the bottom of the graph. There were a significant number of markings where the test group outperformed the control group. However, there were some markings where the control group outperformed the test group, as you can see here. This is where we'll focus the analysis. The results in steps 12 and 13 are only marginal, and it could be argued that those steps were somewhat inconclusive in terms of which group performed better. However, focusing on these steps, it was the control group that was convincingly more successful. The common factor with this is that these are the steps that occurred where there was an opening or a window or a wall in the framing of that particular wall. So in this case, it looks like the control group that used the two-dimensional set of paper plans to mark did better than the test group that used the AR headset. Now, our assumption is that the AR headset does not continuously show all the vertical members that are being constructed, whereas with the two-dimensional paper set of plans, you see that continuously as you're looking at the plans, and so we suspect that may be an idea for the difference. This table describes the NASA Task Load Index survey that we collected from every participant in both the control and the test group. In short, the overall results for the NASA Task Load Index indicate that in all instances the test group perceived less effort. That's the negative score that you're seeing on most of the items there. They perceived less effort during the experience, meaning that the AR tool was not a distraction to them. The one positive, the performance metric, is shown as a higher positive, indicating that they perceived higher level of performance. In conclusion, a few key takeaways. This research does build upon the existing body of knowledge about how AR can impact student learning, and especially in a positive way. The technology did not impose any additional effort on the students' learning. This was found in the NASA TLX surveys that we conducted. AR is much more widespread in the industry, and its adoption in education is practical at the moment. Content is important, and content providing services are maturing. Thank you for your time and listening.